Alright, on these three we're going to classify the pair of lines, like name it, what type of lines they are, and then we'll list how many solutions each system has. So for the first pair of lines we have intersecting lines. They have one point in common, so it's one solution. For the second pair of lines we have coinciding lines, lines that are right on top of each other. And so all the points on one are also on the other, so that's infinitely many solutions. And then this third pair of lines, they are parallel. There's no points in common, so there are no solutions. Here we want to solve by graphing. So for the first line we have a slope of negative 2 over 1 and a y-intercept of 0 because we don't see it. So start at the y-intercept, start at the 0, plot a point, and then rise a negative 2, which means go down 2 and to the right 1. So the first line is graphed. Now the second line, slope is 2 over 1, y-intercept is negative 4. So if the slope's not a fraction already, write it as a fraction. Then you're going to plot your y-intercept and use your slope to find other points. Now you're looking to see which of those cases that you have here, if you think about the last three that we did. So they intersect at one point. Now we're going to name that point. So the point of intersection on this one is the point 1, negative 2. So that's our solution to this system of linear equations. Now 5 through 9 we're going to solve by elimination. Elimination is where you add your equations together, but before we add we need to make sure that we have opposite coefficients. On the y we have a 4 and a negative 4, so those are opposites. When we add them they will be eliminated. That's what we want to have happen. So you already have them lined up in standard form. Negative 5x plus positive 4x is negative 1x, or just negative x. Negative 4y plus positive 4y is 0, it's eliminated. Negative 1 plus 8 is 7. Now to get rid of multiplying by a negative 1, divide both sides by a negative 1. And so x is negative 7. If we found x, we still need to find y, so we're going to substitute this back in. You can go to either equation. I'm noticing that the second one has positives, so it might be a little bit easier to work with. So instead of x, I'm going to put negative 7. Now I'm going to solve this for y. 4 times negative 7 is negative 28. Now we have a two-step equation. To get rid of that negative 28 that's being added to the 4y, you can subtract the negative 28, which is the same thing as adding 28. So if we add 28 to each side, we have 4y equals 36, and now we can divide by 4. And so y is 9. Put it together as an ordered pair, x then y. So we have a pair of intersecting lines, and they intersect at the point negative 7, 9. Number 6. If we add them like they are, nothing's eliminated. So let's multiply one of our equations by negative 1. The reason we're doing negative 1 is because we have the same coefficients. So we need to multiply one of our equations by negative 1. That way we have opposite signs. So we have negative x, and then we'll have minus 5y equals positive 2. If we rewrite the top one below it, now we're ready to add our equations together. Negative x plus positive x is 0, it's eliminated. Negative 5y plus positive 4y is negative 1y, or just negative y. 2 minus 7, or 2 plus a negative 7 is negative 5. Get rid of multiplying by a negative 1, divide both sides by a negative 1, and so you get y equal to 5. Now to find x, we'll plug this back in. So we have x plus 4 times 5 equal to negative 7. 4 times 5 is 20. To To get rid of the plus 20, subtract 20 from each side. And so we have x equal to negative 27. Put it together as an ordered pair, x, then y. Number 7, if we add them like they are, nothing's eliminated. So we're going to multiply the top one. I'll do that top one by, let's say, 6, and the bottom by 2. Notice the coefficients on the y. You already have opposite signs. So it's nice if you just multiply by the 6 and the 2. You could also do 10 on the top and maybe negative 3 on the bottom. Distribute your 6. 6 times 3x is 18x. 6 times negative 2y is negative 12y. And then on the right side, 10 times 6 is 60. Distributing the 2 on the bottom, 2 times 10x is 20x. 2 times 6y is 12y. Notice we have the opposite y coefficients. 8 times 2 is 16. Now we're ready to add our equations together. We get 38x. Y's are eliminated. On the right side, 76. To get rid of multiplying by 38, we can divide both sides by 38. And so we get x equal to 2. Now we're going to take this and substitute it back in. I guess if I go with the top one this time, 3 times 2 minus 2y equals 10. 3 times 2 is 6. Now we're left with a two-step equation. To get rid of the positive 6, subtract 6 from each side. And so we have negative 2y equal to positive 4. Now to get rid of the multiplying by negative 2, divide both sides by negative 2. And so we get y equal to negative 2. Put it together as an ordered pair, x, then y. Number 8. If we add them like they are, nothing's eliminated. So let's multiply. We can multiply the top one maybe by 3. Or excuse me, the bottom one by 3. Top one by 1. Now you have some options if you want to do the bottom one by 6, top one by 2. And there are other choices as well that you might think of. So if we distribute the 1 on top, nothing changes. On the bottom, distribute your 3. 3 times negative 2x is negative 6x. 3 times negative 1y is negative 3y. And on the right side, 3 times negative 6 is negative 18. Add your equations together. On the left side, both variables are eliminated, so make sure you write the 0. If everything's gone from a side of the equation, write the 0 down. Positive 18 plus negative 18 is also 0. So consider this statement, 0 equals 0. That is true, so it is infinitely many solutions. These are coinciding lines. Number 9, we already have opposite coefficients on our x, so we're ready to add them together. Negative 5x plus positive 5x is 0. 8y plus 10y is 18y. On the right side, 10 plus negative 10 is 0. So 18 times y equals 0. To get rid of multiplying by 18, divide by 18. And so we get y equal to 0. Now we're going to take this, substitute it back in. You can go wherever you want with it. I guess I'll go with the top one. Negative 5x plus 8 times y, which is 0, equals 10. 8 times 0 is 0. 0 plus negative 5y is negative 5y, or negative 5x is negative 5x. To get rid of multiplying by negative 5, divide by negative 5 on each side. And so you get x equal to negative 2. Put it together as an ordered pair, x, then y. So you have a pair of intersecting lines, and they intersect at the point, negative 2, 0.